What's up, everyone? We're gonna do a LeetCode Delta question today, which is this one. This question is today's Delta question, and it should be an easy problem. It's just about like how you're gonna optimize it. And the question is really simple. Given an array of string and return the k most frequent string, and it also says that sorted by the frequency from highness to lowness, and if they have same frequency, then sorted by the lexicographical order. And that's about it. This question is really simple, and the test case is also very simple. Cool, and how to solve this problem. So the first idea is like we can break this problem into two steps. I don't think it's possible to do it in like one loop, to do it in one go. So yeah, the first step would be not sorted, but like count the frequency for each individual word. I think that's like our first step. That's what we're gonna do. And the second step, after we count the frequency for individual word, we would like to extract the first k word from above. And that's about it. That's the two steps we need to do. And it's all about like how to do this two step efficiently. And yeah, for doing the first step, count the frequency for each individual word. There's a few ways. One is just use a hash map a string to a count, and yeah, just increment the count for each string. And in this way, the time complexity for each individual operation will be O1 constant time, and for counting an array of words, the time complexity would be ON. Another way to do it, so this is the first way. Let me just write it down. So this is also the way I'm using, which is using a hash table. Another way to do it is using tries, but like I don't feel like using tries because tries doesn't give much improvement. I feel like tries is optimized when you want to search for a word, not for counting a sort of same word. It's not what it's used for. And tries, technically speaking, if we so we know like each individual English word have like certain length, so its operation also can be viewed as O1, which is constant time. Because like each operation, for each operation, insert a word and then insert by char, which is the length of this word, and that's about it. So I don't think like tries will improve its road. I don't even think tries would improve it because things like we might implement it in a recursion way or iterative way. Iterative way might be better, but recursion will definitely make it worse than the hash table. And also hash table is building function in C++ and it's being optimized. So in this way, I was think the hash table is better in these use cases. But in the interview, I think it's was mentioning about tries. Okay, and that's about my first step. That's exactly what I did. Ignore this line. This line is like not for this question. So yeah, just using unordered map, which is hash table to store it and loop through this array. And that's my first step. And then the second step is to would like to extract first k, and we would like just return the first k of above. And this way, like I do have a few idea, but like I don't know. So for this question, the first idea come to my mind is to using a sort. But the problem using a sort, so if we use a sort, then how we gonna compare them? We use the count, the frequency count. We extract it from previous previous step. Just say previous step to sort basically we would do that. But just one problem that I realized is that the words, the whole array have duplicate words, and in order to remove those, we need to create another vector string and to load the word in, and this might take more time. Actually, I might have made some mistake. Actually, sort method might not be that bad because in my previous step, I was using this word array to load this new word element, but I realized that we can just use this hash table to loop through all elements inside of a hash table, and it's guaranteed to be unique, although it's not guaranteed to be sorted. Great, and then the second method come out human is using a map, which is basically a balance search tree. Yeah, binary search tree structure, and this allows. Wait, let me think about it. So yeah, this allows to this step to be O row K row K. Row K is for searching for a particular element, and we need to perform K such operation. And how we compare it is basically the same as the above. And that's what I did here. So we have the vector string return vector string, and then just sort it. And also here the using a set string. And what this set string does is it will automatically sort the string in the order. So yeah, that's like building feature for set string. So I don't have to do additional compare step other than the frequency. And we create this data structure, we just load it in, and then we travel through this this map, which is a binary tree. And that's about it. That's this way. And if we submit, it would give a pretty good result, 88%. But now I'm gonna try to use this sort again, but instead of sorting from words, I'm gonna load from this hash map and see if this gives a much more improvement. Wait, let me think about it. We're gonna sort it. Okay, yeah, let me just like wait a second. Yeah, I realized something. So not forget about it. Let's create two vector string equal vs and for all two pel mp vs dot pushback p dot second, which will guarantee give me a unique set of string. And then I sort the string. Will be const string b, and also I need to capture the map. And suppose that map dot find a dot second is equal to map dot find b dot second, which is the frequency is the same. Then we sorted by the lexicographical order, which is this. Otherwise, we sorted by the frequency, and we want the greater frequency one come first, and that's how we sort it. And we just load it for int I equal to 0, I smaller than k, and I plus plus to put it into the vector. So should be return vs dot pushback vs I, and then return vs. Is it working? Oh wait, I think wait, let me think about it. So the mode matching member. So P second here should be crap. P the first. Yep. And semicolon. Great, and submit. Wait, I want to see like how much I can beat in this way. Okay, it's still slow now, which I don't know why. Maybe as I here I can use in place back. Here, okay, it's in place back. Well, let's make it faster. Nope, it's not making it faster. So I think this way is not efficiency, but I don't know why. Technically speaking, they both unroll just like the coefficient, and I assume the sorting will take more efficiency. I mean, it's less efficient compared to put it into a binary search tree, but that doesn't make too much sense to me. All right, and also just one more thing. So in map, it basically took. Oh, it actually didn't took that much time because you also want to insert it. So it also like take when you insert it, it will be unique word size, which is they denoted as U times log U. U is the unique word size. And if you're using sort, then it should be also like this. So yeah, I think the map and sort is basically the same. To be honest, they are the same. This map can be viewed as sorting by using a binary tree. But just one more way, one more thing that we haven't tried out, which is using a heap, which we can have a rook. I know heap, but the problem with heap is it requires the on computer function, which I didn't figure it out. But I guess I can try. Oh, I need something like this. Remember. And in this case, it took the two string. Wait, actually, wait, let me think about it. Is it a string? Yeah, tier string. I think this one is more complicated and not quite sure like how would I load it to the parallel queue. So anyway, that's two ways to solve this question, and yeah, that's it. And thank you for watching.